All right, welcome to 2.4, day 2. The first thing we're going to do today is a little bit of review. If I do 1/7 plus 3/7, you add the numerators. 1 plus 3 is 4. The denominator stays the same, so that's 4/7. Now, if the denominators are not equal, we have to find a common denominator. A common denominator here, let's make this a little smaller. Could be 33. So we could say that this is 33, 33 on the bottom, and I got 33 by multiplying the 11 and the 3. Now if I multiply this denominator by the 3, I have to multiply the numerator by the 3 to make these equivalent fractions. And on this right hand side, 3 times 11 is 33, so 1 times 11 is 11. Now I just add up 6 plus 11 is 17, so 17/33. Now if we look at this one, we can multiply these denominators again. 5 times 4, or 5 times 9 is 45. So we'll have a 45 in the denominator on both sides. And if we do that, if I multiply the denominator by 5, the top I have to multiply by 5. If I multiply this by 9, the numerator I have to multiply by 9. So the denominator is easy, just stays the same at 45. The numerator, I take 25 plus 18. That would be 43. Now, if I want to simplify the square root of 8, there's a couple different methods. If you know your perfect squares, you think of the largest perfect square that can go into 8, and that would be 4. And so square root of 8 is the square root of 4 times the square root of 2. Now I know the square root of 4 is 2, so this answer is 2 root 2. I cannot take the square root of 2, so I just leave it like that. An alternate method would be to make a tree where you know that this would be root 2, root 4, because those are two numbers that multiply to get to 8. Root 4 is the same thing as root 2, root 2. So once we have a prime number over here, we can say that the square root of 2 times the square root of 2 times the square root of 2. We know the square root of 2 times the square root of 2 is 2, so then it leaves 1 root 2 left in the square root. So either method will work. If I look at the square root of 63, that you can say this is the square root of 9 times the square root of 7, which would be 3 root 7. Square root of 48, this is going to be the square root of 16 times the square root of 3. So this would be 4 times the square root of 3. To rationalize the denominator, we don't want a square root in the denominator, so we multiply the numerator and the denominator by root 7. So this would be 5 root 7 over 7. Well, this would be root 49, and the square root of 49 is 7. Same thing here. This would be root 3 over root 3. So this would be 6 root 3 over 3. Now in this case we can simplify this. 6 divided by 3 is 2. So this will be 2 root 3. If I multiply by root 6 over root 6, this would be 4 root 6 over 6. Now I simplify 4 6 to being 2 thirds. Alright, now if we're looking for the missing side in a 45, 45, 90 triangle, this side's 1, that side's 1, this side will be 1 times the square root of 2. In a 30, 60, 90 triangle, if I have the short side, which is across from the 30, it's supposed to be if that's 1, the hypotenuse is twice that, which is 2, and this side over here is the short side times the square root of 3. Now you have to memorize these triangles. Take a look at this triangle, 30, 60, 90, 45, 45, 90. Those are very important for today's lesson. All right, on this problem, if we have the short side being 5, this side is going to be 5 root 3. Over here, if the short side's 5, the hypotenuse is 10. Now this is a 45, 45, 90 triangle. If that side's 5, this side is going to be 5. and the hypotenuse would be 5 root 2. All right, in this 30, 60, 90 triangle, from my hypotenuse to my longer leg, this would be half of that times the square root of 3, so 7 root 3, and that would make this side over here 7. So we have 14, 7, 7 root 3. All right, now it gets a little tricky. We want to find the exact value of the cosine of 45. So we draw our axes. 45 up is right here. That's supposed to be a 45. Now we fill in our sides. We can do any 45, 45, 90 triangle, but it's easiest to do the most basic one, 1, 1, root 2. So now when I find the cosine, it's my adjacent side, which is 1 over square root of 2. If I rationalize that, that'll be root 2 over 2, which is e. Sine of 135. Now if I do 135, draw my reference triangle, that's going to be a 45, 45, 90 triangle. So I have 1, 1, root 2 again. However, this time we go 1 to left, so that should be a negative 1. Even though that doesn't really affect the problem, we have 1 over root 2, which is again root 2 over 2, which is e. Now just because the first two are root 2 over 2 doesn't mean they're all going to be. Let's try cosine of 240. Cosine of 240, over here is 180, so we go past 180 quite a bit. Looks like we go past by 60. So that makes 30, 60, 90. So that's going to be 1, 2, root 3. Now both of these are going to be negative. So now if I do cosine, it's going to be negative 1 over 2. Tangent of 225. Now if I want to find the tangent of 225, it's going to be down here. Between 225 and 180, it's going to be a 45-degree angle. So I have 1, 1, root 2. And since that's going to left and that's going down, they're negatives. So the tangent is opposite, which is negative 1 over negative 1, which will turn out to be 1. Cosine of negative 60. So that means instead of going counterclockwise, I'm going to go clockwise 60 degrees. So, my machine is going nuts right now. So let's do this one again. So we're going to do 60 degrees clockwise. So 60, 30. So I'll have 1, 2, root 3. And just the root 3 would be negative. So cosine would be 1 over 2, which is f. Sine of 330. 330 was going around till we get down here. 330 would leave 30 degrees between 330 and 360. So that would be negative 1, root 3, and 2. So sine would be negative 1 over 2. Tangent of 315. 315, again, quadrant 4, leaving 45 degrees between 315 and 360. So I have 1. That'll be negative 1 since we're going down, root 2. Tangent is going to be negative 1 over 1, which is negative 1. Cosine of 330. We already looked at 330 before. 330 is down here, leaving at 30 degrees. So that would be negative 1, root 3, and 2. So cosine would be root 3 over 2. Sine of 120. 120, we're going to go up there. That's going to leave 60 degrees between 120 and 180. So we just fill in our sides. And sine would be opposite over hypotenuse, root 3 over 2. Sine of 150. Sine of 150 is going out here, leaving 30 degrees between 150 and 180. So that's going to left root 3, so sine is going to be 1 over 2. cotangent of 150, we can use that same triangle that we drew on the previous page, and now we just have to think about cotangent. Um, Tangent would be 1 over square root of 3, so cotangent would be negative root 3 over 1, which doesn't do much, so it's just negative square root 3. Cosecant of 225. I think we've done 225. It's down here. That's a 45-degree angle. So if we do 1, 1, and both those being negative, and then square root of 2, it's going to be, this is the reciprocal of sine, so it's going to be the square root of 2 over negative 1, which is the same thing as the square root of 2. All right, now let's use Geometry Sketchpad to see what happens at the axes. Now these are our reference angles going around, and if we look at this as we're getting closer and closer to 0 degrees. Maybe I'll... If we're getting closer and closer to 0 degrees, my opposite side is going to get closer and closer to... Oh, I know what I can do. I'm trying to write on this, but... All right. Oop, that's not exactly what I wanted, but that'll do. At 0 degrees, we're going to have the opposite side, the adjacent, and the hypotenuse. Now, this isn't 0, but you can see this opposite side here is pretty close to 0, and it will be 0 as soon as it moves closer to the axis. The adjacent side is going to be 1. It's going to be that distance. And at 0 degrees, the hypotenuse is going to be the same size as the adjacent. However, if you see, watch me move this up to here, notice that the opposite gets bigger and bigger and gets closer and closer to 1. And the adjacent is moving closer and closer to 0. So if I take a capture, if I capture that, where are we at? There we go. If we just look at this part, at 90 degrees, the opposite side is going to get closer and closer to 1. The adjacent side is going to get closer and closer to 0. And the hypotenuse will stay at 1. All right. Now if we move this around down here, my opposite side would be 0. My adjacent side would be negative 1. And my hypotenuse would be 1. And then at 270, you can see my opposite is negative 1, my adjacent side is 0, and my hypotenuse is 1. So let's try to put this all into one table. So let's move this over. Over here we have opposite, adjacent, and hypotenuse. I'm going to see if I can just copy and paste that. That would be a little bit easier for me. Ooh. Do that on each axis. All right. Now at 0, the opposite side is going to be 0. The adjacent side is going to be 1, and the hypotenuse is going to be 1. At 90 degrees, the opposite side is going to be 1, the adjacent side is going to be 0, and the hypotenuse is 1. The hypotenuse is always 1, so that makes it easy. Now, over on at 180 degrees, the opposite side is going to be 0 again. But now the adjacent is -1 because we're going to the left. And at 270, that dot shouldn't be there. It should go -1, 0, and then the hypotenuse is 1. All right, now if you want to find the sine of 180, you can just use those values, or you can try to draw a really small triangle. Think about this triangle. The opposite side here, as this gets to 0, is going to be 0. The hypotenuse is 1. 0 over 1 equals 0. The tangent of 90, again, let's try to draw a triangle, my reference triangle. Here my opposite side is going to be close to 1. At 90 degrees, this adjacent side will be 0. 1 over 0 means it's undefined. Sine of 270, if I draw my reference triangle down below, it would look like this. So my adjacent side will go to 0, my opposite side go to -1, my hypotenuse to 1. So this would be -1 over 1, which is d, -1. Tangent of 180, over here, again, the small triangle. This opposite side will get closer to 0. The adjacent side will get closer and closer to -1. 0 or -1 is 0. Cosine of 90, draw your reference triangle going up. The opposite side is 1. The adjacent side is 0. The hypotenuse is 1. So 0 over 1 is 0. Cotangent of 90, same triangle. We have 0, 1, 1. But cotangent is adjacent over opposite, so 0 over 1, which is 0. Secant of -360. -360 takes it and wraps it all the way around. So let's draw a small reference triangle over here. The opposite side would get closer to 0. That would be 1, 1. Secant is hypotenuse over adjacent. 1 over 1 is 1. Now, here's a cosecant of 225. 225 is down here. If we do -1, -1 root 2, this would be -root 2 over 1, which is -root 2. Cotangent of 150 is going to be out here, where we have 30 degrees, 1, 2, root 3, and that's negative, so it'd be root 3 over 1, negative, which should be E. Now if we have the sine of 210, 210 would be down here, so the sign would be opposite, which would be -1 over 2. So this would be like taking -1/2 and squaring it. So negative times negative will be positive, so it'd be 1 over 4. That's our answer. Cosine of 180 plus sine of 150. If I do cosine of 180, let's do a small triangle over here. The adjacent side would be -1, the hypotenuse would be 1. -1 over 1 is -1. Now if I do the sine of 150, that's up here, 30, 60, 90, so we'd have 1 over the hypotenuse, which is 2. So -1 plus 1/2 would just be -1/2. All right, that's today's assignment. Good luck.